Once again, welcome back to my YouTube channel Sriram Devarajan. Today I am going to discuss another set of problem that was asked in UG TRB 2024 mathematics question paper. I already upload part 1. This is part 2. In part 1, one problem, there is a error in the question that we'll discuss in this video. Later part of my video I will discuss that problem. Today's problem with the first one is if A vector and B vector are irrotational, then A vector cross B vector is option A solenoidal, option B irrotational, option C neither solenoidal nor irrotational, option D both solenoidal and irrotational. Given A and B are irrotational, then what is the value for A vector cross B vector? Whether it is solenoidal or irrotational, neither solenoidal nor irrotational, both solenoidal and irrotational. Since A and B are irrotational, by definition del cross A vector equal to 0 and del cross B vector equal to 0. Now del dot A cross B equivalent to, by well-known result, we can write it as del cross A dot B minus del cross B dot A. This is 0. Again, by definition, if del dot A cross B is 0, we can say A vector cross B vector is solenoidal. For this problem, first option is the correct option. Now the problem number 2, The problem 2, we have to find the zeros of f of z, where f of z is given as z power 3 minus 1 by z power 3 plus 1, whether the first option is the correct one. We have to find the zeros of f of z, where f of z is z cube minus 1 by z cube plus 1, whether the first option is the correct one or second option B. The third one C, 1 comma 1 minus I root 3 by 2 comma 1 plus I root 3 by 2. Last one 1 comma 2I comma minus 2I. Solution: zeros of f of z is, equate the numerator to 0, that is here numerator is z cube minus 1 equal to 0. It can be further written as z minus 1 z square plus z plus 1 equal to 0. Z minus 1 equal to 0 means z equal to 1. Z square plus z plus 1 equal to 0 means z equal to minus 1 plus or minus 1 minus root 3 by 2 minus 1 plus or minus 1 minus minus 1 plus or minus root of 1 minus 4 by 2. It is I root 3 by 2. Therefore zeros are 1 comma minus 1 plus I root 3 by 2 minus 1 minus I root 3 by 2. For this problem, first option is the correct option. Now the third problem, the value of the constant A so that n into x comma y is ax square minus y square plus xy is harmonic. Option A 1, option B 2, option C 3, option D 0. Solution: we have to find the value for the constant A. The given function is n into x comma y is ax square minus y square plus xy is harmonic. Since the function is harmonic, it must satisfy Laplace equation, that is nxx plus nyy equal to 0. Find nx. Since what is n? Ax square minus y square plus xy, 2ax plus y. Find nxx, 2a. Find ny, minus 2y plus x. Find nyy, minus 2. Substitute the value for nxx plus nyy in 1. Therefore 1 implies 2a minus 2 equal to 0, 2a equal to 2, a equal to 1. For this problem, option A is the correct one. Now the problem number 4. By Cauchy residue theorem, integral C f of z dz is equal to option A pi I summation j equal to 1 to n residue of f of z comma zj b 2 pi I summation j equal to 1 to infinity residue of f of z with zj c 2 pi I summation j equal to 1 to n residue of f of z at the point zj. Option D, pi I summation j equal to 1 to infinity residue of f of z at the point zj. See this problem number 4, statement of Cauchy residue theorem. Solution: Cauchy residue theorem. We have to check which option is the correct one for Cauchy residue theorem. Straight away from Cauchy residue theorem, integral c f of z dz equal to 2 pi I into sum of the residues. It can be further written as 2 pi summation j equal to 1 to n function f of z at the point zj. This is sum of the residues. We can write in the form of summation with multiple 2 pi I. This is the statement of Cauchy residue theorem. Of 2 pi I summation j equal to 1 to n residue f of z at the point zj, that is equivalent to integral over c f of z dz. Option C matches the correct statement for Cauchy residue theorem. For this problem number 4, C is the correct option. Problem number 5, center and radius of modulus of z minus 2 minus I, which is equivalent to 3, or option A 2 plus I comma 3, option B 2 minus I comma 3, option C minus 2 plus I comma 3, option D minus 2 minus I comma minus 3. For this problem number 5, we have to find center and radius for modulus of z minus 2 minus I equal to 3. Solution: given modulus of z minus 2 minus I equal to 3 is of the form modulus of z minus z naught equal to r. This r is nothing but radius, this z naught is nothing but center. Right, given modulus of z minus 2I equal to 3 in the form of mod z minus z naught equal to r. Modulus of z which is equal to modulus of z minus 2I modulus of z minus of 2 plus I, which is equal to r. R is nothing but here 3. this is radius, this is center. Therefore center is 2 plus I. What is radius? 3. For this problem, option A is the correct one. Problem number 6, we have to find the radius of convergence for the power series summation n factorial by n power n into z power n, whether the first option A answer is E, second one 1 by E, third one C, last one 1. You have to check which one is the correct one. If you compare given power series with summation an z power n, we get an is n factorial by n power n. That is, we have to find radius of convergence. The formula is r equal to limit n tends to infinity an by an plus 1. This is an, this is an plus 1. Simplifying, limit n tends to infinity n factorial by n power n. This part n plus 1 power n plus 1 by n plus 1 factorial. I am writing n factorial as 1 into 2 into 3 up to n. Take n outside with the power n plus 1. Remaining term 1 plus 1 by n power n plus 1. Denominator n power n. Along with n plus 1, n power n, we have n plus 1 factorial. Write like this: 1, 2, 3, n plus 1. This term will be cancelled. Remaining n power n plus 1, I am writing n power n into n divided by n power n with the term n plus 1 by 1 plus 1 along with 1 plus 1 by n power n plus 1. Again these two will get cancelled. Limit n tends to infinity n by n plus 1, 1 plus 1 by n power n plus 1. Limit n tends to infinity n by n plus 1 into limit n tends to infinity 1 plus 1 by n power n plus 1. If you substitute the limit, this part becomes 0, power n plus 1 becomes infinity. It is of the form 1 power infinity. Whenever if we have 1 power infinity, write like this: e power limit n tends to infinity 1 by n into n plus 1. E power limit n tends to infinity 1 by n into n plus 1. For this n by n plus 1, take n outside the denominator. Limit n tends to infinity n by n into 1 plus 1 by n. Again this term 0. N will get cancelled. Answer is 1. E power limit n tends to infinity n plus 1 by n. Again e power limit n tends to infinity. Take n outside. 1 plus 1 by n by n. N will get cancelled. This part becomes 0 if you substitute or n approaches infinity. What is the answer for this problem? E power 1. Answer is C. Option A is the correct option for this problem. Problem number 7th one. The value of integral C, which is a closed one, dz by z into z square plus 4 C such that mod z equal to 1 is option A pi I, option B pi I by 2, option C 2 pi I, option D pi I by 4. We have to find the integral value dz by z into z square plus 4, where C is the circle which is given as mod z equal to 1. Mod z equal to 1 means unit circle. Whether the first option pi I, second option pi I by 2, third one 2 pi I, last one pi I by 4. Solution. Here for this problem I am going to use Cauchy integral formula. First of all, find the poles. For finding poles, equate denominator to 0. Z into z square plus 4 equivalent to 0, z equal to 0, z equal to plus or minus 2y. Since z square plus 4 equal to 0, z square equal to minus 4. Only z equal to 0 lies inside mod z equal to 1 and 2i minus 2i lie outside the circle. See, this is unit circle, this is a real axis, this is imaginary axis. 0 means origin, that lies inside the circle. Minus 2i means imaginary part, imaginary axis, that is 0, 2. This is 0, plus 2. Both 0, 2, 0, minus 2 lies outside the circle. Imaginary axis, this is real axis. What is Cauchy integral formula? Integral over C f of z dz by z minus a 2 pi I into f of a. Here f of z is 1 by z square plus 4. What is f of a? F of 0, 1 by 4. Therefore 2 pi I into 1 by 4, answer is pi I by 2. Pi I by 2 means option B is the correct option. Problem number 8. The value of integral 0 to infinity t e power minus 3t cos t dt is option A 3 by 13, option B 8 by 25, option C 1 by 25, option D 2 by 25. We have to find the value for this integral. This problem is from Laplace transform. I am going to use the definition of Laplace transform for solving this problem and get the answer and check whether which one is the correct one from the among the 4 options. Solution. What is definition of Laplace transform? L of f of t, which is equivalent to integral 0 to infinity e power minus st f of t dt. Here in this problem, integral 0 to infinity t e power minus 3t cos t dt. I am going to rewrite this one as integral 0 to infinity e power minus 3t t cos t into dt. First of all, I am going to find the value for integral 0 to infinity e power minus st t cos t dt. Then replace s by 3. By definition of Laplace transform, this is L of t cos t. See, inside the operator L, we have f of t that comes inside the integral e power minus t f of t. Here f of t is t cos t. What is L of t cos t? By the property, it can be written as minus d by ds 1 by, sorry, this is cos t. Differentiation, okay, minus d by ds, what is cos t? 1 s by s square plus 1 by the result L of cos t. Now differentiate with respect to s using u by v formula. S square plus 1 the whole square, s square plus 1 into 1 minus s into 2s minus s square plus 1 minus 2s square by s square plus 1 the whole square. Simplification, minus of 1 minus s square by s square plus 1 the whole square. Problem number 8, we have to find the value for integral 0 to infinity t e power minus 3t cos t dt. Among the four options, first one is 3 by 13, second one is 8 by 25, third one 1 by 25, fourth one 2 by 25. This problem is from Laplace transform. I am applying definition of Laplace transform. We know that L of f of t is integral 0 to infinity e power minus st f of t dt. What is given problem? Integral 0 to infinity t e power minus 3t cos t dt, which is equivalent to integral 0 to infinity, write like this, e power minus 3t t cos t dt. Integration of, first of all I am going to find integral 0 to infinity e power minus st t cos t dt. By definition of Laplace transform, this is L of t cos t. Again, by the property in Laplace transform, we can write minus d by ds L of cos t. Again, by the result L of cos t, s by s square plus 1. Differentiate with respect to s, minus of applying u by v, s square plus 1, differentiation of s is 1, s into differentiation of s square plus 1, 2s, divided by s square plus 1 whole square, minus s square plus 1 minus 2s square by s square plus 1 the whole square, minus simplification of s square plus 1 minus 2x square, which is equivalent to minus of 1 minus s square by s square plus 1 the whole square. Simplifying this one, s square minus 1 by s square plus 1 the whole square. Now replace s by 3. The question, this part become integral 0 to infinity e power minus 3t t cos t dt. This is our problem. If we replace s by 3 in RHS, 9 minus 1 8, 9 plus 1 10 square 100, 8 by 100 simplification, answer is 2 by 25. Now I am going to discuss the problem number 9. Problem number 9. The differential equation dy by dx plus py qy power n, where p and q are functions of x only known as option A Legendre equation, B Bessel equation, option C Lagrange equation, option D Bernoulli's equation. Clearly this differential equation dy by dx plus py which is equal to q y power 1 not Legendre, not Bessel, not Lagrange, Bernoulli. Bernoulli's equation is of the form dy by dx plus py q y power n. But the same way one must know first order linear differential equation, that is of the form dy by dx plus py equal to q. Difference between Bernoulli and the first order linear differential equation is here along with q we have y power n, in this second equation only q. Therefore first equation is Bernoulli, second one is first order linear differential equation in y, linear in y. Before proceeding for the last problem in this video, I already mentioned when I solved the problem in this video that there is a problem error in part 1 of UGTRB 2024. The problem is given in the form of reciprocal equation of second type. I already uploaded in the part 1 series. That problem is having some error. The question is a wrong one. They must ask reciprocal equation of second type. Which one of the following is not reciprocal equation of second type means B option correct. 31. The problem already discussed in a previous video, that is part 1. One problem is having error. In the question itself, the error, there is no mention about not second type. One must know in reciprocal equation 4 cases, 2 cases for odd degree, 2 cases for even degree. The problem that was asked already discussed in previous video for odd degree. If the equation is of odd degree with the coefficient of terms equal distance from first and last have same value and the same sign, that is first type. An equation of odd degree with the coefficient of terms equal distance from first and last have same value but opposite sign, that is of second type. The error already I discussed in the previous video. In the question itself they are not mentioning reciprocal equation of second type which is not of second type. Which is not of second type means B correct. If it is of second type, option A is the correct option, since it is asked second type only, not mentioning not second type. Not second type means option B is correct one. If it is of second type, reciprocal equation second type means option A is the correct one. The 10th problem, if root 3 minus I7 is one of the roots of an equation, then you have to find the degree of the equation. Option A 4, option B 3, option C 2, option D 1. We know very well irrational roots occur in pairs and imaginary roots occur in pairs. Root 3 minus I7 is one of the roots means root 3 minus I7, one of the roots means root 3 plus I7 minus root 3 minus I7 minus root 3 plus I7, totally 4 roots. Nth degree equation must have n roots. Here we have 4 roots, means degree must be, therefore degree must be equal to 4. Because of simple concept, nth degree equation must have n roots. Since we have find out 4 roots, means equation degree must be 4. Degree of the equation must be 4. Option A is the correct option. I already upload part 1 of UGTRB 2024. This is part 2 of UGTRB 2024. Already I have solved 10 problems in part 1, another set of 10 problems in part 2. You just go to my YouTube channel, check the playlist, you may get the part 1. Now part 2, I have solved 10 problems. I will solve more problems from UGTRB 2024. Subscribe my channel, share my channel and like my channel. Thank you.